Hello guys, hello Philippines, hello world. This is again, I am a singer, eternal voice. At this moment in time, I will be able to discuss the most common and basic formulas used in science. Okay, it could be physics, chemistry, or any pure sciences. So this will be the formulas that will be used continuously as you go in high school, college, or even you take up your master course. Okay, so this will never end. Okay, so I have here 30 formulas. So there are still basic and common formulas that will not be mentioned here. Okay, please feel free to speak up. These are common and basic formulas, okay, in science. So from 1 to 10, right? Number 1, mass flow rate. Number 2, volumetric flow rate. Number 3, heat. Number 4, energy. Number 5, power. Number 6, work. Number 7, kinetic energy. Number 8, potential energy. Number 9, molar mass. Number 10, molar density. Okay. Number 11, pressure. Okay. So, number 12, density. Number 13, density, sorry. Number 14, mass. Number 15 is volume, it is momentum. Number 18 is speed and velocity. Number 19 is, what's this? Acceleration. Okay. And then number 20 is specific gravity. Number 21 is kinematic viscosity, or the absolute and dynamic viscosity also. Okay, like this. Okay, we have the thermal conductivity. Okay, like that. Too long cannot memorize. So acceleration due to gravity constant. Okay, like this. And we have flux. The other one is theory of relativity. Okay, rate of transfer general. Okay, and then fraction, shear stress, and the last one is Ohm's law. Okay, like this. So every science problems, would it be chemistry, physics, or even higher science or subjects, especially if you're taking up Bachelor of Science related to pure sciences. For example, BS Physics, BS Chemistry, okay, BS Chemical Engineering, something like that, okay, or in a Masters in Chemistry, something like that, okay, or Master of Education, major in Science, okay, like that. So this will be used all, okay. So very basic, we will just use the basic mathematics to solve the problems. If you know the formulas, then you can analyze. It depends on your analysis, how good you are in analyzing the problem, and then apply the formula, and you can solve for the what is being asked in the problem. Okay, so the first thing to do is to analyze, right? I've read first the problem, uh, first, second, and then number two, sorry, you have to write the data. Okay, the data. Number three, you have to write the required, what is being asked. Okay, because through that, what is being asked and what is being required, you can get the exact formula for that. Okay, and then if there are still unknown given, then you have to correlate the different formulas here. Correlate. meaning you have to compare and to have a relationship so that this two or three formulas will be linked with each other so that you can determine the desired quantity to be applied in your formula chosen in your solution. Okay, something it's gonna be like that. Okay, then this is only a technique. So I really do this. I start with basic formulas and foundations. Then later, okay, rises slowly, going to the average, and then rising, and then going to the little difficult, and then average difficult, and then most difficult. But honestly, I'm not concentrating to this part of the difficult problems. I'm just going to the easy, okay, basic problems, and then go to average, above average, and a little difficult only. Not on the average difficult and the higher difficult, because sometimes I will get easily confused also, especially if there are a lot of assumptions. These assumptions can make the examinees confused. Assumptions. So assume all these quantities are constant, like that, for example, only. And sometimes it will never say the assumptions also, and let your analysis will work for those assumptions, something like that. So that make it difficult. Okay, like that. So I'm gonna show you the formula for each. Number one, mass flow rate. This mass flow rate is very important in unit operation and in unit process, in energy and material balances. Okay, I think in all engineering courses, I think so. It's mechanical engineering, chemical engineering. We are applying this. I'm not really sure with other engineering courses, but sure 100% both the chemical engineering and the mechanical engineering. Okay. Chemical engineering and mechanical engineering are both using energy and material balances equation. And this number one, mass flow rate, is very important. Mass flow rate. Okay, I'll show you the formula for mass flow rate. Here in my discussion, I will not be showing you the integral calculus part discussion, differential calculus part discussion, differential equation part discussion, advanced engineering mathematics discussion, because those are only additionals in order to make your understanding, and that is not most of the times in our real world. If you are working, you will never use that integral calculus, differential calculus, differential equation, advanced engineering mathematics. You can only use most of the times the algebra, sometimes trigonometry, geometry, probability and statistics, okay, and basic calculations only. Okay, the four mathematical operations will be used only. Okay. Yes, I will admit that during in the designing stage, and then that's the time you will be able to use a little bit of integral and differential calculus, but it's not also all the time. Okay, because algebra will do, basic mathematics will do really. Okay, even in the higher, in the higher chemical engineering subjects, we are only using sometimes, most of the times also the basic only. Okay, mathematical operations. Unless you are taking the use differential calculus, advanced engineering mathematics, okay, are being part of that the examination for engineering courses. It's in there. You will study. Not really the needed. There are only a part or few, but it's not really. There are problems that can be solved with integral calculus, the same as can be solved in differential calculus, the same as can be solved also in basic algebra. Okay, only the approach of solving the problem is different, but still we can get the same answer. Okay, so me, I would rather go to the basic rather than going to those more not really that complicated, requires too much formulas. Okay, differential calculus D1 to D25, something like that, and integral calculus I1 to I27, something like that. There's a lot of formulas to be followed. Okay, and then you will apply that every time. So that's it. Okay, and sometimes you will miss out. Okay, when the problems to be solved requires the combination of integral, differential, okay, like that. Sometimes really, honestly, you will be lost. Okay, let's say it's an advantage also, but if you take engineering course, you're good in math. Okay, because a lot of mathematics in the general engineering coverage. Okay, and this will be measured when you take the board examination. Okay, administered by Philippine Regulation Commission or PRC. Okay, something like that. There's no question about the major because your major is your expertise, right? But this general engineering or if you're good in mathematics, then you are advantage, something like that. Okay, mass flow rate. Okay, mass flow rate. This is the formula of the mass flow rate. I will show you. Wait, mass flow rate. Okay, mass flow rate can be used most of the times in a continuity equation. Continuity equation, okay, as a part also of energy, okay, like that. So continuity law equation, okay, mass flow rate 1 is equals to the mass flow rate 2. Okay, in a steady state flow, chemical reaction or any types of fluid flow, okay, situation, something like or ideal gas or whatever. Okay, so mass flow rate is since this is mass flow rate, guys, the numerator will be in mass. It could be in kilogram, in gram, and in pound, or in tons, something like that. Okay. So mass flow rate will be, let's just have an acronym to denote, so to make it understandable. So let's say MFR. This one. MFR is an acronym for mass flow rate. Is equals to the density of the fluid or a gas. Let's just denote the density as the rho in Greek symbol, rho, like this. This is a rho, a Greek symbol that is used in our old scientists in the past, because they're using this symbols most of the time, especially in the nuclear chemistry, okay, and the nuclear transmutation, okay, or radioactivity, something like that. Density times the area and the velocity. Okay, this one. This is the formula. Okay, now if the problem will ask for the velocity or speed, then you can compute right away if these other quantities will be given after your analysis, depending on the problem you solve. Okay? But then if the fluid is water, it is understood to have a standard density of 1,000 kilogram per cubic meter, 1 gram per ml, and 1 gram per cc or cubic centimeter at 4 degrees Celsius. Normally, the problem will not mention this. We just state a water flowing to blah, 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 so and so. So you will use directly the standard density value. You choose the density value which is will agree to the other units of this other quantities such as area and velocity and speed. Okay, so we will just agree here that we will be using the word velocity, not the speed, though it is the same, right? The unit is meter per second, feet per second, like that. but we just use velocity because we are concerned for the direction where the fluid goes, like that, from point A to point B to point C to point D and goes back to point A, blah, blah, blah. So let's put this as velocity. Or you can treat that as speed. It depends on you, but for me, I'll treat that as a velocity because that's a vector quantity. Okay, the direction of fluid or a gas is very important. Okay, so this is the mass flow rate. Okay, then if you are given with another substances, for example, use the density by looking to the different values in the physical properties and chemical properties listed in the textbooks, in the indexes or in different tables presented there. Okay, just go to the table of contents. Okay, or you can use the Paris Chemical Engineer's Handbook. It's also listed there. Okay, it's written there. All you have to do is to read and scan properly so that you can see those values of densities at various temperature. Because if the temperature also will change, for example, water at 16 degrees Celsius is flowing in a pipeline like that. You will never use any more than 1,000 kilogram per cubic meter. Understand? This is also one mistake of some examinees. Because if the teacher is always using the 1,000 kilogram per cubic meter, the 1 gram per ml, and the 1 gram per cc, then they still keep on using that even though the temperature in the problem of the water is already different. Understand? This standard, if there's no temperature given, automatically use the standard density value. And then she will go, but if the temperature was mentioned, it is not already 1,000 kilogram per cubic meter. It is not 1 gram per ml. It is not 1 gram per cc the density, even though that is water. So go to the indexes, to the table, and look for the temperatures at a certain temperatures from 0 degrees Celsius and to 100 degrees Celsius and the rest, and then try to locate that in the table. And then you can get the density. Never use the standard anymore because the density is dependent with temperature. Unless the problem is not stating the temperature, then use directly the standard values of density. This is the technique. Okay? If you are, really taking up an engineering course. Okay? Because all of the engineering students will push in the board examination. Okay? Like that. Okay. So the units, be careful with the units that it will agree. If you use metric system, then use also meters like this, seconds. If you are using the English, then use pound, feet, like that. Okay. You will just know that somewhere along the way of your solution. Okay, number 2. Volumetric flow rate. The unit of this, sorry, I come back. The unit of this mass work could either be kilogram, okay, per second. Okay, kilogram per second. Okay, because that is a rate. As I told you a while ago, the unit of the mass flow rate is kilogram per second because that is a rate. Just put that in your mind that if it is a rate, it always have the time in the denominator. Time, meaning it could either be second, minute, an hour. For example, the problem will say, what is the rate of this particular substance that will react to this, like this, blah, blah, blah. So your answer must be have a second always in the denominator, minute, hour, it depends on the problem. Okay, because that is a rate. So this is a mass flow rate, that's why kilogram per second, right? It could be gram per second, right? It could be pound per second. It could be ton per second. Anything mass, unit over time, unit. That is mass flow rate. Okay? And then we have the volumetric flow rate. volumetric flow rate is equals to area times the velocity or the speed. Okay. This one. In the volumetric flow rate, you will be happy because the density will be removed. Okay. You will be happy because the density value will be removed. So it is in this case also that we have to analyze the situation of the problem. For example, if the density is not really an issue and then it will become constant somewhere along the way, like that we treat that as a constant because it never affect really the movement of the fluid, then it could be treated as constant. There's also like that, and especially also the problem is asking for the volume in the required and in the solution. For example, what rate of this fluid A? In your problem, there's no density given there, and it is not water also. Okay, and there's no temperature, so automatically you can substitute that. Okay, like that. Okay, you have to analyze also. Sometimes given mass only, and you have to go to the volumetric flow rate, and then use first the mass flow rate formula before you go to the volumetric flow rate formula, something like that. And then you have to convert using the conversion factor. Okay, the unit for this volumetric flow rate is, since it is volume, in the numerator, let's say cubic meter per second. Cubic meter is a volume. Okay, or it could be cubic centimeter per second. It could be gallon per second. It could be liter per second. Anything that is in terms of volume, that is your numerator. Or anything, the time is denominator. So that is your volumetric flow rate. Okay, but usually expressed in pound, like that's pound per second, kilogram per second. Okay. So it is also the problem sometimes because they will ask in the examination a unit that is not common to the students during the discussion of the professor or instructor in the in the university or institution. Sometimes they will use the not frequently used unit also. Okay, that's why it made us confused. Okay, as an this value about, for example, micron, ganon. Then you have really to, oh my god, so it's gonna be like this, okay, and you have to scan the handbook like this. There are new terms sometimes also will be given in the problem, okay, and then it's in actual, you will find what's really the unit for this, like this, okay, but because it is not explained and presented most of the times in the problem also, okay. Like that. For example, I give you the unit for the pressure, the PSFG. PSFG, that this unit of pressure is not usually expressed in the problem solving. That's usually the pressure being used in the problem solving that our instructors are discussing. Okay, but in the board examination, it will become another unit in which you are not familiar with. But you are familiar with, but they use it unexpectedly. And then sometimes they will abbreviate also, like PSFG. And then this G is a gauge pressure. If you are not really doing your reading and you did not read a lot, then sometimes you cannot also understand because you did not encounter something like that, okay? The PSIA, A is the absolute. Okay, so pound per square inch absolute. That is absolute pressure. And then there's also gauge pressure. So if there's like that, then you will not use automatically the 1 atmosphere, standard pressure. You have still to compute. Okay, so some students also will substitute directly, including me sometimes. Okay, that's why. Okay, and then we substitute that because it's a unit of pressure. We don't know that it's still absolute. It's not still. It is not yet a gauge pressure, something like that. Okay, we have to analyze. Okay, so that's it. So number 3, heat. I love heat. Heat is represented as Q, capital Q lang. Actually, it could be small. It's studied also in chemistry. In chemistry, heat is being studied also, but in thermodynamics, it's really the focus is this heat. Okay, thermal energy. Okay, heat. The formula of heat is Q to mcp/dt. So this formula is very overused because this will come out most of the time in the board examination. Always like this, okay? Really sure. It will really come out. Okay, so like this, Q is equals to mcp/dt. So mass is the mass of a substance or solid, or simply the heat capacity, something like that. And then the dt is the change in temperature. Okay, the final temperature minus the initial temperature, or shall we say the temperature difference. Okay, or the temperature gradient. Okay, or temperature changes, terms you want to. Okay, as long as that is the difference from final and initial temperatures. Okay, QMCP. Since here you are dealing with the change on the different formulas of temperature. If you are an engineering course right now, first year or high school temperature, you want to become an engineer. Okay, frankly speaking, because if you will not memorize the formulas of temperatures, then you'll suffer when you reach college, because engineering course is 5 years and you will use most of the time this temperatures overused in engineering course, especially in thermodynamics. Not only in thermodynamics, a lot of subjects will use temperature, right? I'll show you here. Degree Celsius. I'll show you the technique so that you can memorize easily. Okay, degree Celsius is equals to, so if we say degrees, that's only small. Okay, 9, pila man na siya. Pwede mo say, wait ha, 5 divided by 9. That is 0.56. But for me, as an engineer, I will just memorize that as a 5/9. Because I don't want point something. Okay, and then decimal places, 6, something like that. Okay, times, close and open minus 3 only, that it is always small, meaning say 5/9. And then on the side, there's a subtraction. That's the clue of memorization. Okay, so there's a subtraction in the side. So you will say degree Celsius 5/9 times. Okay, and then the degrees Fahrenheit, it's B. Okay, it's B. So 9/5 reverse. Okay, 9/5, and then there's no close open parentheses. Okay, just multiply that directly to the degree Celsius. Yes, plus 32. Okay, so you will wonder why. The one, okay, just memorize in that manner. Degree Celsius. So there are only 4 temperature formulas. Okay, memorize that. Then bingo. If you memorize these formulas of temperatures all the time in your brain cells, then you can use this in your MCPDT without scanning the handbook, without scanning the textbooks. Because sometimes it will take time also. Just to by yourself, you can get exactly what you want. Refer back again the book, the handbook, like that. Okay. So just so I told you, you have technique to do that. Okay. So ganito, there are 4 formulas of temperature only. Okay. And the degrees Rankine. Okay, the Kelvin has no degree. It is not special that it has degrees, no 0 at the top. Okay, you will never say degrees Kelvin, huh? It's only Kelvin. That's wrong if you put degrees above the Kelvin. Okay, because Kelvin is only Kelvin. Okay, like that. So the problem will convert. Okay, because sometimes the specific standard value of water, 1 calorie per gram degree Celsius. Okay, something like that. 1 calorie per gram degrees Celsius. Now, if the temperature given in the problem is Rankine, how can you do that? And you are used to the specific heat value which don't contain Rankine, then you convert Rankine to Celsius. So that it will agree and it will be cancelled out somewhere along the way. Okay, something like that. Okay, so be careful. Ganon. Okay. So specific heat capacity can be used interchangeably. Don't be confused. Some books are using specific heat capacity, and some books also using only specific heat, and some books also are only using heat capacity. That's the same. Only the terminology has been changed. Just look over the unit. That is the most precise. Okay? But the perfect is the specific heat capacity. What I mean is, it can also be known as heat capacity only 1 calorie per gram degrees Celsius. Okay. Ganon. Now, kung problema na po ka sa calorie, then convert. 1 calorie is equal to 4.184 joules. Okay. Like that. So, we have the specific heat, you have the temperature, we have the mass. The mass also in terms of kilogram, gram, pound. This one. So, you can agree with me and bingo. You can solve for the value of each quantity that is being required in the problem. It depends only in your analysis on how you analyze the problem. Okay, because every one of us has different analysis or different IQ, intelligent quotient. There are some very fast, okay, to get the correct analysis. And sometimes also others, individual are very slow to get the analysis. Okay, like that. And so others also are average only, not fast, not slow. It's in the middle only. So that's why. Okay, okay. That is for heat. And heat plus is energy. Okay, heat. Since that is an energy, the unit of heat is in. Okay, joule, calorie, kilocalorie, like that. It can be also sometimes erg, you know erg, okay? This is energy, right? BTU, British Thermal Unit, BTU, okay? So there's a value for British Thermal Unit also, and convert to this one, and then you can solve for the conversion factors, okay? Like that. So you can equate that also to another energy equations, okay? Because that is heat is an energy. Especially if you treat the system as steady state, okay, and in equilibrium with the other fluids, something like or gas, then you can equate, then you can solve for other quantities also. Okay? Equate mo siya. Okay. Number 4, energy. This energy is mechanical energy, the mechanical energy. Let's enumerate. Okay, and let's just remember this energy, pneumatic energy, hydraulic and thermal energy. So 10 na siya. And radioactive energy. Okay, 11. And there's still more, right? I think if there are still more, but based on my knowledge, there are only 11 energies we have existing in our world. Plus this heat energy or the thermal energy. So 12, right? 12 energies we have. Okay, so each energy we have to study. Okay, if this energy, each energy has its own formula to govern, and then you have to equate that to another energy formulas also. If you really love, problem solving, recurring thermodynamics, like that, or if you really want to take up engineering course, then memorize all the energies formulas to make sure. Talaga. Energy, okay, let's give the formula for energy. Ganon. Okay, class. After this, we'll be able to have an exam, okay, to measure your test, to test and to measure your intelligence capability. Ganun talaga. And to measure your charot. Energy is equal to work. As if the basic definition of work is the capacity, energy is the capacity to do work. In elementary, I think in grades, energy is the, and the unit of energy is just the same, okay, erg, okay, like that. Okay, so since it is equal to work, and then we have the formula of work, which is force times distance. Okay, work, distance. Ganon. This is the formula of work, force times distance. Okay, the force in Newton. Okay, Newton, or it could be in dyne, dyne. Okay, like that. And the distance could be in meter, the English unit, or a metric unit. It depends on the problem you want to solve. Okay? The force is in Newton, and Newton is equal to kilogram, okay, meter per second squared. This is the equivalent of Newton. Okay? Newton is the same as kilogram, meter per second squared. Remember this class because this will really come out in different examinations. Okay, and this is very useful in conversion, especially you are taking physics like this, thermodynamics. Okay, there's a lot of energies there also, unit processes, unit operations like this, and the energy and material balances also. Okay, this Newton. Okay. And now we have also the dyne. Okay, capital D. This is the dyne. Okay, the dyne. This dyne is not used all the time. That's why the problem in the board examination sometimes, always examiners are not familiar with this all the time because most of the examples of the instructors and professors in the universities or in the institutions are always in terms of Newton, frankly speaking. Now, as a student, you have to research for another unit that is equal for Newton. Okay? Same unit all the time. Because what if the problem will give another unit and you will be lost? Because every time your instructor are giving the unit which is commonly used all the time. You get the point? Okay, and then you will be shocked during examination. I didn't encounter this. So it's your fault. Why you did not go to the library and research for another unit of force? It's not the fault of the instructors and the professors, by the way, in the first place. It's all your fault because you did not research and use your initiative to go to the library and search for another unit because there's so many units in it. Okay, and you must compare one of the other. And if you cannot understand, go to another book, scan in the library. Okay, like this. Spend your, okay. So D is equals to dyne. That's really a technique. Okay. So D is equal to dyne. So dyne or D is equals to gram, centimeter per second squared. Okay. Okay, this one. Dyne is equals to gram, okay, centimeter per second squared. Okay, and then the Newton is kilometer per second squared, which is most common. So memorize this dyne from now on. Okay, dyne is another unit of force. So gram, centimeter per second squared. Now, if the problems will give dyne also, then bingo, you can't solve the problem anymore. Okay? You can solve already. You will not find difficulty and search and scan to the books. I didn't encounter this one. Okay, like that, blah, 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 blah. So, okay. Now, this is the unit of force. And then for energy, okay? Force na siyang duha, ha? Energy is joule. Memorize all the basic, really. That's a technique in passing examinations. Okay, always expressed in the problems. If it is not a joule, it is calorie. If it is a calorie, it is BTU. Or if it is a BTU, that is an erg. And that is a unit of energy or work. Now let's break down this one by one. Joule is equals to Newton meter because force times distance. Okay. Okay, next. So joules, Newton meter. Okay. Now the erg is dyne centimeter. See, dyne centimeter is the erg. And the example we have examination today. Put the dyne centimeter. For example, a person have a 25 dyne centimeter. Do not be afraid because that is the unit of energy. That is erg. A person produce 28 erg of energy because you did not understand what is an erg. You get the point? Okay, because an erg is a unit of energy and work. You use the formula of work and energy, which is force times distance. Okay, this is the most common problems of, including me, most of the examinees encounter because we are used for the most common lang siya. We don't explore the other units for that particular quantity. Okay, and we have also British thermal unit, which is BTU. Okay, this unit also of energy. Okay, and the calorie, which is the most common one. That's why we have how many out jogging, exercise, we release our energy. Okay, like that. The formula is also force times distance. Okay, like this. So energy. Okay, and now in terms of fluid flow in the pipeline, so another formula will be discussed. Work is equal to the change in kinetic energy or the summation of all kinetic energy in the particular points from pipeline number 1, pipeline number 2, pipeline number 3, and ganon. Okay? The change in kinetic energy, meaning the summation, ganon. Okay? In the final stage, minus the kinetic energy in the initial stage. Ganon. Okay? Plus the change of potential energy in the final stage and change of potential energy in the initial stage. Okay. Actually, this is the formula, another formula for the work. So the change of kinetic energy in the final minus the change of kinetic energy in the initial plus the change of kinetic potential energy in the final minus the change of potential energy in the initial. It looks starting to be difficult, right? But never mind, okay? So now we will cancel the potential energy most of the times because the fluid are moving. The fluid are moving, the liquid are moving, the particles of matter are moving, could either be solid, liquid, and gas, of course. If there are different concentration gradients, for example, different chemical reactions, chemical substances are being combined, then they will move, they will collide with each other, bombarding with each other, the molecules with each other, and create a strong intermolecular forces. So, in that alone, potential energy will be 0. So that's why we will cancel this one. It's equals to 0. Okay? Since that is equal to 0, what we left is work is equals to the change in kinetic energy final minus the change of kinetic energy initial. So this is your another formula of work in terms of movement and motion of a gas or a liquid. Okay, not necessarily a person or a car, because this first work came, okay, the motion of a heavy equipment, always the distance covered, it could be vertical, upward, vertical, upward. The other one is a motion of solid particles of matter. And then in that airplane, there's no viscosity there. That's not a fluid. So it will matter a lot. There's some quantities that are being applied there. For example, the viscosity, okay, the diffusion coefficient, mga ganun siya. Density. Don't you think there's a density? If a person will walk from point A to point B, no, there's no density. But in this other reaction, it will be considered, this other formula, the density will be considered, the viscosity will be considered, the specific gravity will be considered. This is the motion of fluid and liquid. That's why, but the same formula, the same only word. The applicability ba? Okay? So you will also analyze the applicability of the formula. Hindi kaya basta-basta magamit lang po formula, di mo analyze kung asa siya i-apply. Okay? Ganon. If it is a concentration, physical movement, okay? This is force times distance, okay? This is, okay? But this is most of the times in physics, ha? The first one, the work is also force times distance. Okay? So like this. For example, the problem will say, what is the energy of Mr. Sotero if he has a force of 2 Newton? I'm using the word energy. Okay, it's just the same. Use the formula of work. I told you earlier, energy is the capacity to do work. So technically, energy is equal to work. Okay, do not too literal. Okay, in memorizing the formulas. Okay, that's analysis. Okay, some problems also will never mention directly, but it has the same meaning with other formulas also. For example, shear stress. Okay, shear stress has the same unit with pressure. Remember that one. Okay, and then shear stress is also shear force over the surface area. And sometimes it could only be interpreted as pressure. It's also force over area. Now, if the problem will give shear stress, now you can answer already because you are used with the word pressure. Okay, that's the technique. In taking examination, word examination like that, there's a trick. Okay, that's why I told you all the time, focus on the unit. Because the unit could identify that this is really the quantity they are referring to. Because shear stress and pressure have the same unit. Okay? Ganon. Okay. Number 5, power. Oh, this is the favorite of electrical engineers and electronics communication engineer students. Okay? Power. What is power, Sir Sotero? Power, okay. That is the work exerted over time. Okay? So, time pala siya if we speak of power. Yes, that's also a rate if we talk about power. Okay? So, power is equals to the work, right? The efficiency of the machine like that, or asking for the voltage or the current flow from point A to point B, then we can solve also because we have the other formula of work. Okay, you get the point? For example, this is a fluid, liquid, and ideal gas. And then we have the formula power is equals to work over time. Okay, then somewhere along the way, the question was saying, what is the power of the carbon dioxide in going to the point A, point B? You cannot answer already because you are used to solving problems with regards only with resistance, voltage, ganon, inductance, capacitance, okay, electricity, theories. You are used to the, okay, because there are 2 laws in electricity, the Kirchhoff's law, and already because it was mixed a formula like condition met with each other or parallel with each other. You analyze, okay, like that. Our formula is power is supposed to work over time, okay? Like that. And if we're given the force, we can compare electricity, like this. It's not like that. Power, okay. So there's time, right? Okay. Power is supposed to work over below. Here, calorie per second, BTU per second. The formula. Okay, 1,000 watts, 2,000 watts, 2,500 kilowatts, that's all per second in this formula. Okay, and then in college, it's okay because some are memorized already. Okay. Now, if your memorization fails, then do the derivation, okay, derive and correlate with each other until such time you can obtain a desired formula. Sometimes memory fails also, and I admit that. Okay, so check the unit. Okay, and then you can analyze. Okay, you can feel it somewhere along the way in your solution, right? Okay, that's kinetic energy. 1/2 times the mass times the velocity with the power 2 and this squared. Okay, the mass. Mass is an object in terms of kilogram, pound, blah, 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 so and so. Velocity in meter per second or feet per second. That's the kinetic energy. So, kinetic energy, right? So, potential energy, number 8. Potential energy is equal to mgh. Wow. mgh. Okay. Potential energy is equal to mgh. Distance or height is not the horizontal distance. Because if you substitute also the horizontal distance covered by an object, the unit also will be same. But that is not the horizontal distance. That is the elevation or the height or the vertical distance. Okay. Potential energy is the mass of an object times the gravity of an object times the height and the elevation. The gravity is always 9.81 meter per second squared in metric system. Okay, memorize this, ha? Okay. This will never change. Okay. Namatay na lang kayo lahat. This gravity will never change. 9.81 meter per second squared. And then for the feet, okay, 32.2 feet per second squared. English unit. Okay. This one. Okay, class, memorize this. Okay. Acceleration due to gravity or gravity itself is 9.81 meter per second squared for metric system. For English is 32.2, okay, feet per second squared. Okay, like that. Since this is acceleration due to gravity, this is raised to the power 2. This is not a velocity, ha? This is not a speed. This is acceleration due to gravity or the gravity alone will do. It's just the same. If we mean gravity, that is acceleration due to gravity. Okay? So always raise to the power 2. Okay? Number 9, molar mass. Oh my gosh, molar. It's not familiar with other engineering courses, but I think so they're studying chemistry because in chemistry, general chemistry are common to all engineering courses in the first year. Okay? We studied a lot of chemistry the same, all engineering students. So they understand also molar mass. Though it is not their focus because they are not into chemistry because they are like that, but they also learn for this general chemistry. Okay, so molar mass. Okay, the description could tell also molar mass. That is mole. Okay, M-O-L-E. Okay, what is a mole? Explain. What is the definition of a mole? Okay, a mole is a unit of the amount of a substance. Okay, that's mole, M-O-L-E. Okay, and it's very useful in chemical reactions. Okay, so molar mass is equal to the molecular weight times the or atomic weight. Atomic weight if solo element or solo metal. Okay, molecular weight is a compound composed of 2 or more elements binded together. Okay, so use the correct and precise terminology. Okay, if it is an atomic weight or formula weight alone, it is only one element or one non-metal or metal. If it is a molecular weight, the word molecule composed of 2 or more atoms or 2 or more elements like that, blah, blah, blah. So if it's a molecular weight, that's a compound composed of 2 or more elements, could either be non-metals or metals. Okay, so this is molecular weight. I'll choose molecular weight because most of the times we will be dealing with compounds. Okay, the reactions and things like that. Okay. Molecular weight, I'll just put this as a NWT times the number of moles N. Okay, like that. This is more in chemistry. This is molar mass. Molar mass is equal to molecular weight times N. Small n means mole, M-O-L-E, the unit of the amount of the. Why tertiary is a molar mass? Since if we put the unit of molecular weight, so the unit of an atomic weight or molecular is always gram per mole. You do not forget that one. And if you times this with mole, okay, gram per mole is the molecular weight times the mole, then the moles cancel out. What left is gram. Okay, that's why it's called molar mass, because the moles are being used to produce a unit of gram. Okay, molar mass. Okay, that is not a mass only, because the formula of mass only is another thing. Okay, right? Density is equal to mass over volume. Okay, that's another thing. This is molar mass only. Okay, number 10, molar density. Okay, we also come out in examination sometimes, and you will be confused because our chapters also are usually using the mass only and the density only. But sometimes the problem will use the molar density of, let's say, cyclohexane. Okay, as this one. It will go to the pipe with a velocity of blah blah blah, so and so. What is the volume of the cyclohexane? It will go to the pipe and on. And then you will never understand because there's a molar density. What's molar density? And molar density has not the same unit with the density of the water, density of organic food, because it's a term molar. Get the point? So you will also use the word mole. Okay, molar density. So what is the formula of density? The original density without molar. Okay. So red a lot. Okay, so we will learn more also. Okay. So molar density. So we know that density is mass over volume, right? So mass over volume, so that is gram per cubic meter. Cubic meter is a volume. And it could be also gram per cubic milliliter. Milliliter is a volume. Now, in molar density, our numerator will change, but the denominator is still the volume. Okay? So since we use mole, that is already mole per cubic meter. Okay? Mole per cubic meter. Okay. Mole per liter. Ganon. Then mole per cubic centimeter or cc. Okay. Mole. Basta volume siya. Mole per gallon. Okay? So that is the molar density now. Molar density is equal to mole per cubic meter, mole per liter, mole per cc or cubic centimeter, mole per gallon. The denominator density. Okay? Like that. It's always used also in the problem solving sometimes. And you will also be confused. You will use the density. You will force to use the density. But that is not the density that we are understand most of the time. This is having the mole. Okay? But some students, not all, okay, will be deceived and confused. So if you will use this density water kilogram per cubic meter, then you will be wrong. So your answer will be wrong. Okay, this is a trick for this. Okay? Molar density and density is not equal. Okay? You understand? Because molar density applies the principle of mole, confirm that it is different. Okay? And sometimes the problem solving also like this. Okay, and you will never understand what's mole per cubic meter. Okay? That is molar density already. Okay? Like that. And then you will compute and the problem will ask, what is the volumetric flow rate? Oh, ganon. Then use the formula here. Okay? Ganon lang siya kasimple. Okay? Charot. Okay. Number 11. Okay, very nice. Number 11, guys, or class, is the pressure. I love pressure. Wow. If there's too much pressure, then I will become active to do and accomplish my task as a safety engineer. Wow. Okay, like that. If there's too much pressure, I'll become energetic and very dynamic to do the things that I love the most. Wow. Okay. So if there's pressure, it always accompanied with force. Okay. So pressure is equals to force over area. Okay. It will be used in the higher difficult subjects. Okay, like that, and you can easily understand also equal. Okay, because you learn about the basic concepts. Okay. Okay, guys, mga future engineers, listen to me. Wow. Okay. Pressure. Okay. Pressure. This is the way how to understand basic. We should go on the details, okay? Like this. Pressure. Pressure is a force exerted on an object. That's the straightforward definition of a pressure. Exerted in perpendicular to the surface area. That is a pressure. So when you listen to the definitions I uttered a while ago, or I spoke a while ago, force is always mentioned in my math, right? So it's governed with a force. Okay, so force over area. Okay. Ganun. So what is the unit of force? Class. Force in terms of kilogram per second per Newton. Okay. Area is square meters. Actually, you can also use feet also if you want, but I love metric system. If you're a student right now, or preparing for your board examination, like that, blah, 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 so on. So go to the library and search for other units like that. Not be dependent only in one unit. Go to other, or discover by yourself. Oh my gosh, like this. Okay. So that to explore with such possibilities. Okay, so square meter. Okay. Oh, Newton per square meter is a unit of pressure. Okay. Oh my gosh. Like that. Okay. Now, another unit of pressure is derived from the basic formula of pressure, but we have also the units of pressures that is automatic or standards, okay, that we should memorize. Okay. Standard value of pressures, 1 atmosphere. Okay. You get your pen now and put in your notebook if you want to take examination, especially for examination. That is 1 atmosphere. Okay. 760 mmHg. Okay. 14.7 psi. And we have also bar or atmosphere because we lack the 0.013 bar, right? 1.013 bar, okay, is equals to 1 atmosphere. Actually, 1 bar is equals to 1 atmosphere. They neglect the 0.013 because it is just very small to account in the solution in the problem. Okay, that's the main reason for some books. Okay, but to be precise and technically correct, just memorize the point something. Okay, to make it sure. So it is 1.013 really is the bar. So 1 atmosphere is equal to 1.013 bar, not 1 bar. But it's up to you if you use the 1 bar also. It would be okay, but I'm just telling you the technically correct and precise value of that bar is 1.013 bar. Okay? Maybe we don't know the choices is very near in the problem, then if you use only 1 and this 0.0 something will matters also. Okay? So much better if you memorize that 1.013 bar. Right? Okay? And we have also the in terms of Pascal. Oh, I love Mr. Pascal. So Pascal discovered the theory of pressure. That's why the unit of pressure is Pascal, because this Mr. Pascal discovered the pressure theory. That's right. Pascal theory of gases. Ganon. Pascal's law of gases. Okay? And he has also another counterpart, Mr. Dalton. Okay, Dalton's law of partial pressures. Okay, that states that the total pressure of a system is equal to the partial pressure of each component of that system. Okay, so PT is equal to P1, P2, P3, P for the shock. Okay, but this Pascal, only this formula achieved. V is equal to F over H. Siya talaga ang original for this. Dalton is only revival. Okay, but this Pascal really is the original because one atmosphere is equals to 101,325 Pascal. Di ba ang sarap pakinggan? His last name is the unit of pressure. Okay, because he discovered pressure thing or pressure theory. Okay, so since we have 101,325 Pascal, then automatically we have 101.325 kilopascal. Okay, guys, I need to write this one, the kilopascal, because in my part also, I don't have to move 3 zeros on the left, 3 zeros on the right. Actually, we know that principle already in mathematics, right? If it is in the negative exponent, you will move the zero on the negative side, negative, on the right, left side, ganon. You move, okay, you from the left side, negative, positive kilopascal. So that I am no longer trying 201.325 kilopascal is equal to 1 atmosphere. So these are standards as STP, standard temperature and pressure, with a temperature of 0 degrees Celsius, meaning to say 273 Kelvin, right? Kelvin, the formula of Kelvin Celsius also 73, right? Something like that. Since that is 0 degrees Celsius, the Kelvin will be 273 Kelvin. There's also standard. That's why standard temperature and pressure. Okay? And take note, class, that in standard temperature and pressure for mole. An ideal 1 mole of gas will occupy 24.414 liters or liters. Okay, because that is occupy man siya. Okay? The mole will never occupy, it's the volume. It's ganun siya. If you try to correct, then you can understand, right? Okay, if you know the quantity. If it is volume, it will occupy, it will move up, it will down, like that. It's liters, not the mole, right? The mole is the unit of substance measure. So it is 1 mole of an ideal gas will occupy 24.414 liter. These pressures. Okay? Like that. Okay? So it's very clear, huh? Okay. So if the question will say, what is the temperature at STP? And there's a choices there in the examination. A, B, C, D. So automatically 0 degrees. You did not see 0 degrees Celsius there. So probably it was converted to another unit. It could be Rankine, Fahrenheit, Kelvin, not. You have to convert. Okay, already discussed that one, right? Okay. That is pressure, equals force over area, Newton per square meter. Okay? Okay. Now we go to the number 12. Again, this is a head elevation pressure. I super with these guys because I will never forget this. When I was in school, I joined chemistry quiz goal, a written quiz goal. Okay, because I was champion in our high school chemistry quiz goal, right? Then I go to the city to compete with other schools also. Okay, together with our. I don't know how to solve really with this. Okay, you know, like that. So I come to a point that I should memorize this one so that I can be able to use this in college, something like that. Okay, since then it is very useful also to take up chemical engineering. Okay, because pressure will be used all the time, especially in dealing with ideal gas laws. Okay, like that. So head and elevation pressure and Bernoulli equation of flow with flow, right? Okay. Number 12. Okay. Okay, wala. Okay. Because I love chemistry too much. That's why. Head elevation pressure. Head elevation pressure is equal to head elevation pressure is equal to the height. This one. Wow. So there's a cumulative pressure palagi siya. Another formula for pressure is equal to the gravity times density times the height, or density times the height placement. It could either be density times height times gravity, or gravity times density. It can be pressure to say, the height must be first, height, density. Okay? Like that. For example, say, okay, you can rumble anywhere if it's multiple. Okay, so the gravity is again 9.81 the acceleration of gravity is energy. Okay, now the density, it varies in terms of the temperature and pressure. It varies chemistry textbooks or in the chemical engineer's handbook also, or any reference chemistry book. The volume density varies at certain temperature. Okay, most of the room. So the substitute na. So pressure is